this is a little different format, but I just thought we would just have a conversation here. And so, Dale, we'll just get started. We'll just start by talking a little bit about, can you tell us about the company you work for, what you did, and how you were a part of that?
Okay. In 1966, I accepted a job at Laclede Steel in Alton. I had a degree in metallurgical engineering from Rolla, and shortly after I got there, they were bidding on a big job in Lower Manhattan, and I didn't realize at the time that I would subsequently get involved in that. Laclede is a kind of a middle-sized steel company. They had a rated capacity of 800,000 tons. And they were divided into two divisions. Half of the company was industrial products, which was welded pipe, oil-tempered wire, and hot rolled products, bars, plates, and coiled strip. And the other half of the company, which is the one I'll be talking about today, is the construction side. And the big product there was steel joists, or the rest of the world refers to them as trusses. And they're what you see in the ceilings of warehouses and Walmart and Costco, places like that where they have the open trusses. And so we were also pioneers in microalloying steels, which was a new type of family of steels that was, well, it was real new at that time. And as it turned out, Laclede's combination of making trusses and big volume trusses and microalloying was the key to us getting the job. As it turned out, we made all the floor trusses for the Twin Towers. And one of the requirements that the New York Port Authority, who was in charge of the project, had, they wanted to have a degreed metallurgist be, I guess, an overseer of all the certifications of the steel, because it was a big, massive testing program. Because of the design of the Twin Towers, it required a very high-strength steel with weldability at the same time, which the numbers that they threw at us were unheard of at that time. We had never made a steel like what they were requesting, and the architect was a guy named Mirani Yamasoto or something like that. Anyway, I forget his name, but he was an architect from, well, he spent a little time in St. Louis, actually. He was originally from Seattle, and he designed the Pruitt-Igoe project in St. Louis, for which he got no notoriety, and the Cochrane Apartments in St. Louis. But the one job he did that put him on the map was he designed the airport terminal at Lambert Field and received international notoriety for it. In fact, that airport has been duplicated all over the world now with the arched ceilings. So the Port Authority, I've got to say a little bit about them because they were the key player in the Twin Towers. The Port Authority, as I understand it, started in like the mid-1920s when New York saw that there was so much infrastructure to look after, bridges, tunnels, dock facilities, that they created this municipal entity called the New York Port Authority. And after I got working with them and started realizing what all they did, I think there was kind of a cross between a municipal engineering company and a Corps of Engineers type of. They were responsible for the management of projects, and they had this reputation for always getting jobs done below budget and ahead of schedule. And their other main attribute that served New York City very well was that whatever the customer wanted, the Port Authority tried very hard to give it to them, give them what they wanted. And in the case of the Twin Towers, it's one lesson could be learned from that is be careful what you wish for, because you might get it. And so The Port Authority was assigned to take on this project. This was a project that actually started back in the mid-1940s, right after the war. New York had two problems, or two objectives, I guess would be a better word for it, that they wanted to accomplish in Lower Manhattan. Lower Manhattan was getting to be a rundown area of New York City. They weren't proud of it anymore. And they wanted to upgrade the Lower Manhattan area. And the other thing was that they had this dream primarily pushed by the Rockefellers. They wanted to create a financial center in New York City that would be considered the world's financial center, so that New York, without question, that would be the premier financial center of the world. And I don't know, there was a lot of bickering and finance problems and
Politics.
just all sorts of problems that went on for about the next 10 years. And then as Nelson Rockefeller became the governor of the state and his brother David was the chairman of the Chase Manhattan Bank, things got more serious because they really wanted to build this trade center. And so the New York Port Authority went to work to find an architect to build such a center. And they went through a lot of architects that were big name architects in New York City and around the world, and they submitted proposed plans for a World Trade Center. The Port Authority rejected them all. They wanted to think a little bit more out of the box, outside the box. And so this Yamasaki guy, who by this time has started up a small company up in Birmingham, near Detroit, Birmingham, Michigan, they went to him, and he submitted preliminary plans for these twin towers. And the people at the Port Authority, I forget the guy's name, his name was Austin, but I forget his last name. But anyhow, he was the head of the Port Authority at that time. I'm drawing all this from memory, and I didn't think I would ever have to talk about this in my life, because in 1966, it was just another job. It was a beginner job. I was the last kid in, so I was the first one to get this assignment because the senior people at Laclede knew this would be just a clerk type job, really. All I did was take test results and compare them against the specification, and I mean, anyone could have done it. But the Port Authority was a very governmental-like organization. They insisted that a metallurgist do this. But anyhow, back to New York, this Yamasaki got the job, and then they laid all the requirements on him. The word got out about that they were going to build twin towers, that we're going to build a World Trade Center in New York. And so every financial company in the world that was anybody wanted in on it. They wanted space there. And the Port Authority was overwhelmed with requests for space. And another thing that all the people who had desired space there wanted, they wanted open floor plans. They wanted no beams in the way. And when they started looking at Mr. Yamasaki's plans, they started putting all the numbers together, and they said, we've got to build a building that will have more space in it than a conventional building, a 110-story building. Both of these towers were 110 stories. And so Mr. Yamasaki and an engineering company in New York went to work on, okay, now how can we give them the desires they're looking for. And so they came up with this plan to build more or less a hollow structure with a core. And let me backtrack here. For a building that size, the elevators that would be needed to service a building like size would leave very little space for occupancy. And so the big factor in all this was they had to figure out how to get the elevator space in the structure and still have the occupancy. So Mr. Yamasaki came up with this brilliant idea, really. He would stack the elevators. He divided the building into, the lower part of the building went from floor 1 to 41, I believe, where there was a mezzanine, and that was one set of elevators, local elevators that serviced that part of the building. And then from 41 up to 70, I think it was 70 or 71, was a second set of elevators, and another mezzanine up at the 70th floor, and then a third set of elevators. And then to complement them and get people to those mezzanines, there was express elevators that only made a stop on the 40th, the 70th, and the top of the building. There was a restaurant on top of the North Tower.
Wow.
So anyhow, that reduced the amount of space in the building that would be taken up by elevators and staircases. There were 3 staircases in each tower, and they went from the top to the bottom. The only way you could have survived on 9/11, was if you were on one of the 3 staircases on the South Tower. The rest of them had already been damaged so badly and blocked by the debris from the initial hit of the planes that there was no way of getting out. And as it turned out, the only survivors, people who said they survived, they got out, they were on that one staircase. So here you've got a core of the building, and you've got walls that are made of rectangular tubes, which is what you see on the outside of the building. And they had plates welded to those outside bars, and then they brought those up as units. It was probably the first modular high-rise building ever built in the world. All of the outside beams that you see in pictures, those were modularized. They were built on the ground and then hoisted up and put in place. And the bar or the plate that went on the inside of those vertical beams was where our trusses welded to. They had little clips welded to the inside of those plates, and our trusses sat on those clips, and they were bolted into a little notched section. One of the interesting things about the towers is they deflected a lot, and so they actually built them such that the outside they called it a curtain wall. The outside curtain wall could deflect, and the inside of the building would not move. And they would slide on those notches inside the building.
110 stories high.
Yeah,
And they couldn't feel movement on the top?
No, there were times when they recorded wind velocities of 100 miles an hour up in those upper floors. So you actually had periods of time when the outside walls were doing this, and the people inside were not moving at all. But some people said that they could feel it a little bit on real windy days. They could feel it a little bit because there was a small path on these little notches. So anyhow, you've got these trusses coming in from Laclede Steel and Alton, and they're being fabricated into units, being welded together, and they're going up with each outside wall piece, and they're being clipped onto the inside of the outside wall and the outside of the elevator pod, where it was enclosed in plates. And you had no structural steel from the elevator pod to the outside wall. No one had ever built a building like this before. And the reason there was such a demand for the high-strength steel, and they wanted somebody to make sure it was high strength, was because that was integral to building the Twin Towers. Normally you would have vertical and horizontal beams. They would take the compressive load of the building, and the horizontal beams would support and keep stable the vertical load. A beam in compression is very strong. Well, we had nothing like that in the towers. There was no structural steel. And Mr. Yamasaki at the time got all kinds of accolades because this design got them 75% occupancy space. In those days, 50% occupancy space was like normal. And so they picked up, with this design, with stacking elevators, they picked up 25% occupancy space. And so everybody was happy. Mr. Yamasaki, in the end, got criticized by structural engineers. They said, your building is kind of flimsy. We've never heard of anybody building like this. And he got compliments because of course, it was a miracle to get 75% occupancy in a building like that. It was unheard of. Nobody had ever done it before. So that's how the Twin Towers were built. And for 28 years, that worked fine. The engineering that he put into that, the design, it worked fine. And had it not been for 9/11, those buildings would still be working fine.
We chatted a lot, before this, obviously, and, I believe there's tragedies in every generation that mark a generation, that we all remember where we were, what we were doing, whether that was December 7th, 1941, or is it 41? Pearl Harbor Day, or the day Kennedy was shot was another one of those days. And I believe September 11th is that tragedy that defines our generation. And, I'm sure you all were watching TV, those of you that are old enough to remember this. And I remember watching the towers standing there, burning, had been hit. And I remember thinking, oh my gosh, if they fall over, they're going to kill so many people, but maybe by some fluke, someone might survive that. But then you're sitting there watching them and they collapsed one on top of the other down. And as soon as I saw that, immediately my thought was, no one survived that. As Dale said, each of those floors was cement. So they made those on the ground, the frame of steel with cement, and then they raised them into place. So all those layers coming down, I immediately, it was so heartbreaking to think no one was surviving that. And what were your thoughts, when you saw the towers had been hit?
Yeah.
And about how the building collapsed?
I walked in, I was at Ozarks Federal at the time, and somebody told me there that a plane had hit one of the towers, and I could not believe it. I hurried home and I watched these two planes hit the towers, and the towers come down. I will say this though, the way the towers came down was totally what I would have expected. I never would have expected anything like this to happen. The inhumanity of it all is just, it's breathtaking. But the towers themselves were, somebody who was really, had given a lot of thought to how they took those towers down. At the point at which the planes hit the towers, I think it was one tower, the North Tower was like at 12 floors down, the other one was 15. And then what happened was all the flight fuel burning, kerosene, it didn't melt. It didn't melt the trusses. It just weakened the trusses. And all the effort we put in at Laclede to hit this tight chemistry, and we put in vanadium and columbium as grain refiners and strengtheners. And that was sort of new technology too, to be able to get this high strength and then to see it all go up in smoke in one day. But what happened on 9/11 was the towers or the floors immediately above the entrance of the plane, they got very hot, red hot, and got soft. I mean, you can take steel that can be very strong, and you heat it up to 2,300 degrees, and it's like a soft steel. And so they negated the benefit of all that strengthening that we put into those trusses. And then the clips upon which the trusses rested, they got red hot too, and they started weakening. And then the weight, there was a 4-inch layer of concrete on every floor. They put the trusses in place, poured a 4-inch layer of concrete, well, they put a plate down to hold the concrete, put 4 inches of concrete down, and then they fireproofed underneath. They fireproofed so it could withstand, but the fireproofing on a 3/4 inch round bar or small angle, it spalls off real quickly. And so the fireproofing was kind of a waste of time with that intense heat. So the floors started breaking loose from their anchors, and the weight of the concrete, well, the trusses were bowing, and the weight of the concrete on the floors was breaking and pushing down on them. And there was nothing to hold them. There was no structural steel there. And they just started collapsing until 10 or 12 floors. The period of time when the planes hit, and the period of time it took before the building collapsed in free fall was the time it took for the steel to sag and pull away from its anchors and finally just break loose and start piling up. When so much weight piled up at the point of entry, the trusses below that, which were still high-strength trusses, could no longer hold that weight. And as each subsequent layer went down and hit the next floor, it was a heavier load. And so from the point of entry of the planes till the towers dropped was almost free fall. I think they said one of them went down in 11 seconds, the other one in 13 seconds. No one really knows how long it took those towers to come down because there was this massive cloud of dust. There was asbestos in that dust. There was, just, it was unfit to breathe. But, that's how the towers came down, and there's been a lot of conjecture about, what if this and what if that, but my own personal opinion, had there been structural steel in those buildings, which they didn't even build a plane the size of a 767 in 1966. A 707 was the largest commercial plane at that time, and even Boeing hadn't got a plane that size on the drawing board yet. The fuel load was at least double what a 707, maybe even triple the fuel load. And the momentum of a Boeing 767, people have said, well, how can a plane made of titanium and aluminum break through steel bars? But with enough momentum it can, and it did. A lot of conjecture about what would have happened if the towers had been made conventional style. One thing that may not have happened at all, because the people who perpetrated this thing might have said, we can't take these buildings down with that structural steel in there. So it would not have even happened. And I would go along, I would think that would be true. But even if someone did try it, at the very least, the structural steel would have delayed, it would have allowed everybody from below the point at which the plane entered to escape the building. It wouldn't have been 40 or 50 minutes, it would have been, the structural steel would have held a lot longer than that, maybe it wouldn't have even, it may have held indefinitely, so the building cooled off. That's quite possible too. So when you think back on lessons about 9/11 and the Twin Towers, one thing is people were wanting these open floor plans, and they were wanting all this space and occupancy space, and no one, how could you ever imagine that this would happen? Like I said before, you got to be careful what you wish for sometimes, particularly in new designs of things where safety is involved. And then there's another side story back at Laclede. This project did a lot to take our company down. About halfway through the project, the Port Authority, they had unique cranes on these twin towers. They were calling them jumping kangaroos or something like that. They found them in Australia. They were able to take the panels up and get them in place faster than anything that had been devised before that. And so it speeded up production. And the simplicity without the structural steel speeded up production. So about halfway through the project, they got back to us at Laclede and said, you got to speed up. There'll be heavy fines if you don't get steel here faster than you're getting it now. We had agreed on a schedule of deliveries, and now they wanted us to speed them up. So that we resulted in us having to turn back orders of our regular customers and not accept orders from our existing customers. When the project was over, we went back to these people, and 4 years, 2 years of accepting no orders. We went back to our customers and said, hey, we're here again now and we're ready to accept your orders. And they said, when we needed you, you didn't need us, and now we don't need you. And so all of a sudden, Laclede was faced with about a 60% bookings for a melt shop. Oh, by the way, these furnaces were the largest in the world, largest electric arc furnaces in the world, and they had just been built when I got there. And we put in a process called continuous casting, which was new to the world. It's now the standard all over the world, but it was new to the world then. And it was, it was a place that the reason I went to work there is because I thought it was a place that was on the leading edge of a lot of technical fronts. This micro alloying, we were using that in our pipe production and in some of our plate steels, and it was really taking off good. And all of a sudden we do this diamond in the haystack, and when we remove the diamond, the haystack's gone. And if you've ever worked in a melting plant, you can't really make money at a melt shop running 15 shifts a week. A melt shop has to be a continuous operation. It runs best when it runs 20 shifts a week with one downturn, one downshift for repairs. And here we were running it at 15% capacity and taking a lot of low-priced products that just to fill the order book. And so the 1970s were really a bad time for the company. And, we had to fill this order book up. And so what we did, we went into Germany and we bought a rolling mill that was a precision rolling mill that would give us the ability to enter a new product line called special quality bars. And it's mainly the automotive industry. And it took us the better part of a decade to get that product line up and running and get accepted, trial orders and get accepted. And but once we got accepted, we moved into a crowded product line, and everybody place in our company they were pessimistic about it. They said there's so many suppliers and they've been around so long. But when they started using our product, they found that it was better than what they'd been using. And so that product line took off, and it's still, Alton Steel is still operating today, and that's their only product line, is that product line that we developed as a result of the Twin Towers project. So I guess the lesson I've learned from that is, I've worked at Laclede for 31 years, is that don't be afraid of getting into a crowded market somewhere. I always use the analogy, if there's 3 pizza parlors on a corner, don't be afraid to put a 4th one on the 4th corner. But the one thing you got to do is make sure you have better quality. Quality always sells, and it's a sure way of selling. And our product took off, and we just pushed a lot of the other suppliers. They reduced their orders, and we kind of elbowed our way in. And so, back to your first question. I really didn't answer your first question. I worked there for 31 years, and then after that, I worked as a consultant in melting and casting for IPSCO Steel up in Davenport for 10 years. And then I did some work for Cuyahoga Steel and Wire in Cleveland. And the last 2 years I worked a full-time job was up at Alton Steel, which was the steel company that took over Laclede Steel after Laclede Steel finally went bankrupt. But
And that was immediate following the World Trade Center that it went bankrupt. Is that correct?
actually they were both in the same time period. I'm not sure which one came first because I was away from there then. But yeah, it happened.
Mm-hmm.
Laclede Steel went down and the Twin Towers went down at the same time period. But there were some interesting things about working with the Twin Towers. Every floor of the Twin Towers took 1 acre. It's kind of hard to fathom that your floor is an acre of land, but there were 220 acres of usable floor space on the Twin Towers. And the Twin Towers they were 9 buildings on the property. There were the 2 towers and then several smaller buildings, but the entire property only encompassed 16 acres of land. So when we were building the trusses for the Twin Towers, they had to go up first because we had to use the land to put together these panels to put them up. The other interesting thing about it was during the project of building the Twin Towers, Manhattan grew 100 acres because to start with, to build the towers, they had to go down to bedrock to make a foundation for the towers. And it was 6 stories down from the ground level.
Wow.
To bedrock. So all that had to come out of the ground. Plus, the location where the towers were built was an area called Radio Row. It was a rundown area of electronic shops, and a lot of the owners were getting close to retirement. It was kind of there were a few restaurants there, but it was a rundown area. And they took eminent domain to remove all those. There was a lot of. And in a short sentence, there was a lot of political maneuvering and all. And I remember at the time, John Lindsay, I think the guy's name was, he was the mayor, and he finally, through a lot of lawsuits back and forth between the owners of these buildings, he finally just said, we're going to take eminent domain and take the property. And these people were moved up to another part of Manhattan Island. But they took all the debris from the demolition of those buildings and put that out on the Hudson River to create this 100 extra acres. And there's now a little community out there of businesses that are on land that didn't exist before the Twin Towers were built.
Dale, there are so many fascinating aspects to this story, and I will tell you, I've had the chance to visit with him on a couple of occasions about this, and there's even more that we don't have time for today. He was telling me about how the trusses were 60 feet long, and they railed them in, and they didn't have the curvature on the railway wouldn't accommodate the 60-foot rails, so they had to relay the railroad track to accommodate those beams.
That was in the Pocono Mountains. Yeah.
Just incredible history.
The only complaint we ever got from the Port Authority that I was aware of was that we put these 60-foot trusses on rail cars with blocking that had carpet over it, wood blocking that had carpeting, because we put a 2 mil coating of paint on all these trusses. And when they arrived, the inspector at the Port Authority, they had to be covered with this paint. So they called us and they said, we've got scuffs on your paint, so your paint's removed. Well, we delivered these trusses to New Jersey because we didn't have a rail siding at the Port Authority site. So stevedores would then transload these trusses from our rail cars into barges, and then they would ferry them across the Hudson River to the Port Authority site. And these stevedores were getting careless with handling our trusses, and they would arrive over there. They'd leave the plant in perfect condition, they'd drive over there with these, they called them holidays, where the paint was removed. But that, you know, as far as the quality and all went, the quality was good. The one weak thing that hurt Laclede in the process was not only the loss of customers, but because the chemistry necessary to make the mechanical properties were so tight, we had to hit a very small window of chemistry, and it was hard for our melters to do that in those days, and we had to divert a fair number of heats to high-cost rebar, about what it amounted to. But
as you can tell, there are a lot of great business lessons woven throughout this story. Everything from the community development aspect of the Port Authority and the city and their vision for improving that area, all the way down to Alton Steel, Laclede Steel in Alton, and how they managed their production and employees. Just layers and layers of examples of business lessons throughout the story. So you can see why, aside from the historical fascinating aspect of the whole thing, why this is such a great presentation for all of you. And I wish we had time for more, Dale. And I had to twist your arm, and you didn't need me at all. Yes. We hope in the future, so another fascinating story, this also came out at the dining room table, is Dale was also one of the first people to analyze the steel from the wreckage of the Titanic. And he has some fascinating stories about that. So we're hoping to get on his calendar and book him next year for one of our luncheons to talk about that. When we started talking about this, I had thought we might be able to cover both, and he was like, oh no, there is way too much. And he was exactly right, of course, but it's just so wonderful to have you here. Thank you so much for sharing with us.
Thanks for having me.